Okay, so good morning everyone, while waiting for the others to join. So probably we should start with the lecture first, and then in the middle, you will present your project, and then we will continue with another session of lecture. Is that okay for today?
Okay.
Okay. So last meeting, we discussed about decision under uncertainty. Do you remember? So our topic is decision under decision analysis. Can you hear?
Yes. Yes.
So last meeting we discussed about how people make decision, and then we continue with decision under uncertainty, right? And today we discuss about decision under risk and under utility. Okay, in the beginning we discussed about what is risk and uncertainty. As a review, we need to summarize what is decision under uncertainty, and then what is the difference between under uncertainty and under risk. And then we go a little bit deeper into decision under risk. Okay. And if it is possible, we can continue until a risk analysis today. Okay, so last time we have discussed decision under certainty and decision under uncertainty. Decision under certainty means you are sure that good decision will produce good outcomes. Okay? And bad decision will produce bad outcomes. But in reality, that is not happening, right? So then we discuss about decision under uncertainty. These are the whole topic in decision analysis. So today we discuss about decision under risk. Next, we discuss about decision under utility, and then group decision making. And later on, we discuss about game theory, which is decision under conflict. Okay, so what is uncertainty, right? So what is uncertainty? So uncertainty refers to not knowing what will happen in the future. It means if you have no data, or you have only little data available, or it is very expensive or time consuming to get data, not even have any probability information, then your decision must be under uncertainty, right? So now, what is risk? Risk is uncertainty, similar, associated with undesirable outcomes as a result of action or inaction. But the difference between decision under uncertainty and under risk is only one. We do have good probability information. Okay. So here is a comparison. Okay. First, we have decision under uncertainty. What is decision under uncertainty? It is a single person decision-making problem. Okay. So the probability distribution of the state of nature is unknown. Hey, probability distribution here is probability distribution of the state of nature, not the alternative. Now, next, decision is based on criterion, okay, and there is a range between pessimistic to optimistic or somewhere in between, and it can be based on gain payoff or cost payoff. We have discussed last meeting, right, about several criterion: maximin, minimax, maximax, minimin, Laplace, and what is the suffix? Recret rule, and then Hurwitz rule, right? So it's completed. Yeah. My question to you, is there any question about last meeting? Do you know how to compute using Recret? Do you know how to use Laplace equal probability? Do you know how to compute Hurwitz rule? Is there any question?
I guess not.
You have, so you are really okay with that? Okay, so then next is today with this decision under risk. Okay, again, this is still single person decision making problem. When you have more than one person, that is in the domain of game theory. Okay. Decision under uncertainty, decision under risk, and decision under utility is one person decision making problem. Now, in here, in decision under risk, the probability distribution of the occurrence of each state of nature is known. So how do you get that probability? This is called subjective probability. Okay. As you may know, we have three types of probability. Okay. Maybe I should show you the slide. Where did I put it? Let's share you the screen of probability. Here it is. So can you see it? There are three kind of view about probability. One is based on frequency. So probability is basically a long run relative frequency. So you can get the data, okay, and as a sample, and then you divide by the total number of sample. Each of these are called probability. The second view is that probability is a kind of objective chance. So you learn that if you toss a coin, the chance of 50-50, you get the head or you get the tail. Similarly, if you toss a dice, for example, you have a chance of 1/6 for each face of the dice. So this is a kind of objective chance. Similarly, you can also think that probability based on certain theoretical distributions such as binomial, Poisson, and so on. Next, the third view of probability is epistemic probability. It means that probability actually represents knowledge, information, some belief of you as decision agent. So in this view, probability is subjective. So you decide the probability, and then over time you revise your own probability to be better and better based on the information. Now back to the previous slide. Right. So in here, in decision under risk, when we say probability distribution, we are adopting the third view, epistemic probability. Okay, with the subjective probability, you decide the probability distribution. Next, how to compute? The computation of decision is based on expected value approach. Okay, so now you have good information about the probability distribution of the occurrence of each state of nature. You may or may not have the same information of probability for each alternative. Okay. Now, if you use the table, then you assume the probability of occurrence for each alternative are equal. But this assumption can be released later under decision tree, as we can see later. Okay, now here it is. If you use decision under race, okay, you have n state of nature. So I call it S1, S2 until Sn. And then you have alternative. You have M alternative. You have A alternative 1, alternative 2, A1, A2 until M. Say, suppose this is your gain. Then you have, for each alternative, you have, and for each state of nature, you have G11, G12, and so on until Gnn. Okay, this is given. The same thing with the probability for each state of nature. Okay, you have P1 until Pn. So in here, the subscript index is K for its state of nature and J for its alternative. Are you still with me?
Yes.
Okay. So can you distinguish this and last lecture? It's exactly the same except the first row, probability. Okay. So this part is the one that is different. This part is the one that is different. Okay.
Okay.
In nature. Okay. Next. So expected value. An approach to select decision alternative that is based on expected value for each decision alternative. Now, what is the best decision alternative or recommended decision alternative is the one that provide the best expected value. Oh, the best here can be maximum or minimum. Okay, so if it is gain, then of course you want to maximize. If it is cost, then you want to minimize, right? So then this is important. The assumption, you must not make it wrong, okay? Because the assumption is that the alternatives are uncorrelated. You cannot make a hierarchy between alternatives. Okay? The alternative must be uncorrelated. For example, you cannot make, oh, this is a bus, and then you have blue bus, red bus. You cannot do that. Because when you do that, red bus and blue bus is actually correlated with bus. Right? Next. Here is the formula to compute. It's rather simple. So if you have GJK, that is gain, then multiply by PK, which is the probability for each K. What is that? K is representing the state of nature. Okay. Then you sum for all state of nature, K, 1 to N. Then you get the average of gain, right? Then if you want to get what is the decision, simply get the argmax. Okay. You simply get the argument of the maximum. Similarly, if you have cost, then again, you multiply the cost with its probability, probability of each state of nature. Then you sum for all state of nature, you get the average, and then now you get the minimum because it is cost. Clear, eh? So let's take example. So we use the same example as last time. These are the number that you probably recorded last time. So, and the only difference here is I give you the information regarding the probability distribution. So if the probability is 1/3, 1/3, 1/3, then you have Laplace. right?
Yeah.
So now the probability distribution is known. It's not 1/3. But you know that state of nature N1 is actually larger than N2 and N3 is larger than N2. Okay. And then you assign 0.5, 0.2, 0.3. The sum of probability must be 1. Right?
Yep.
Okay, then to compute this, you just multiply. Say, for example, in decision alternative A, you multiply 5 multiplied by 0.5, right? That's 2.5. And then 7 multiplied by 0.2, so 1.4, plus 9 multiplied by 0.3. So if you sum all of that, you get 6.6. Okay. So then you compute again for decision alternative B and C. Then you get the EMV, expected monetary value, or expected value, EV. Then you get the maximum. Of course, the maximum in here is 6.6. Then you get the arc max, which is A, right? So then you say, okay, if this is the payoff table, I will decide A, okay, with EMV of 6.6. So if you compare this with Laplace criterion, the difference is actually on the state of nature. Okay. So a game is called fair game if the EV or the EMV is actually 0. Now, for your practice, tell me, suppose you have a game with this outcome. 20% chance of winning is 100, 30% chance of winning is 50, and 50 chance of winning nothing. You have to pay only $20 to join the game. So the question is that game fair or not? Anyone? So who can get the answer first will get the recitation for this practice. Calculate now.
No.
So what is the EV?
The EV is 35, I think.
Very good, Abel.
Yeah. Okay.
So the EV is 20%, right? Times 100, 30% times 50, and 50% times 0. If you sum, you get 35. So the EV is not 0. Okay. In this case, positive. So the game is unfair, but you see that the AV or the AMV is higher than what you pay, right? You pay 20, and over time you get 35. That means you will win that game in the long run if you play often. On average, you will gain $15. Right. So that is the concept of EMV or EV. Now, sometimes you will decide not only one type of decision, but you may have sequence of decision, right? So then you want to ask, what is the path of that decision that actually the best? So in this case, you will create what is called decision tree. And the best path is called decision strategy. Okay? So the decision strategy is a strategy involving a sequence of decision and decision and chances outcome to provide an optimal solution for your decision problem. So decision tree is a tool, graphical tool, to help you in making decision. Okay. Now, here it is. It's basically tree data structure. Okay. You know, tree have root, and then you have the trunk, and you have some branches, and you have some leaf at the end, right? So this is a simplified model of a tree. So you have, similarly, you have root, okay? And then you have three types of node in this case. You have decision node, which is the branch, are alternative. And you have chance nodes, where the branch are the state of nature. Then at the end, you have leaf node. Okay? So leaf node, we don't have any symbol, but for decision node, we usually symbolize with rectangle or a square, and then chance node is using circle. Okay. Now, if it is a decision node, then you maximize the EV for all branches. If it is the chance node, then you summarize, okay, the sum of the probability multiplied by the EV. Okay. Now, if it is a leaf node, then you multiply the payoff with the branch probability. Okay. So it seems abstract to you at that point, but let us see with the example. Okay. Here it is. So we have what is called fruit store problem. Okay, let me explain what is fruit store problem. So this is an inventory of fruit store, very simple problem. So if the demand is high, you want to order a lot of fruit for your store so that you can gain much profit, right? This is the logic. Now, if the demand is high and you have ordered only a little of that fruit item, you will lose opportunity to sell. Now, if the demand is low and you have ordered too much, the fruit become perish and you lost a lot. Now, if demand is low and you have only little fruit, okay, you only gain little profit. So using this, you can actually put into a decision tree. Okay. So suppose we have this fruit store problem. Now, you see here at the beginning, in the left, you have a square, blue square here represent decision node, right? So what are the alternative? Big order or small order? Now for big order, now you see the yellow circle here represent the chance node. So for the chance, you have high demand or low demand, right? So now you set the probability of high demand, in this case 0.6 and 0.4. Okay. Then at the end, you put the payoff, which is the gain in here. So if you have big order and high demand, then the payoff is 100. If you have big order and low demand, the payoff is minus 100. If you have small order and high demand, the payoff is minus 10. And again, if you have small order and low demand, the payoff is 50. Okay. Can you see that the high demand for big order and small order are the same probability distribution? Okay. But actually, you don't need to make it the same. Okay. For big order and small order, high demand and low demand probability can be different in this case if you use a decision tree. But if you use table, this is a little bit difficult to change. Until here, is there any question? Can you draw the decision tree of your problem?
Yeah.
Easy, right? So remember you have decision node, which represent alternative, and you have chance node represent the state of nature. Okay. In the chance node, you set the probability. At the end, in the leaf node, you have the payoff. Okay. Now, for every payoff matrix, there is corresponding decision tree. But the reverse is not true. Okay. Not all decision tree can be converted into payoff matrix. My question to you, why? Anyone have idea why you can convert payoff matrix into decision tree, but not the other way around? You cannot convert, not all decision tree can be converted to a payoff matrix.
Because the probability is different.
Correct. When the probability is different, okay, for each decision, correct, then you cannot make it into payoff matrix. Okay. Okay. Question to you. Convert the decision tree of fruit problem into payoff matrix. Can you do it? So draw it and then you share your screen. I will allow you to share your screen. Pause the screen. Okay, you can share your screen. So this is your recitation. If you do it, this is your recitation. So 6%. Who did not come today?
Rodney.
Rodney, Michael. So who want to share?
Still drawing.
Okay, still drawing. Do it. So can you convert decision tree of fruit problem into a payoff matrix? Okay, Abel.
Isn't it like this?
Yeah, very good. Very good.
Okay.
Okay, so you can claim your recitation.
Okay.
Okay, very good. So let me continue then. Right, this is the result, right? So based on this decision tree, you can easily put into payoff matrix. Why? Because the probability of high demand and low demand is the state of nature in this case are the same, right? But if you put it different, then you cannot make payoff matrix anymore, meaning that your decision tree are too complex already for a matrix. So what is the meaning of this? Meaning that decision tree is more general than payoff matrix, okay? So how to solve decision tree? Okay. So to find the optimum decision alternative from decision tree, okay, number one, you compute the EV for each leaf. So you start with the leaf. And then you compute the EV for the chance node. And then you compute the maximum EV for decision node. After that, you identify the best decision. Okay, these are the steps. Okay, I'll give you example. So what is the best decision alternative for the fruit store problem? So this is the payoff matrix and this is the decision tree, right? You have it. So first thing first, you compute the EV for each leaf. So here the EV is for high demand, big order, you have 100, right? And the probability is 0.6. So you calculate 0.6 times 100, you get 60, right? The same thing with big order, low demand, small order, high demand, and small order, low demand. You compute EV for the leaf. So you get 60 minus 40 minus 6 and 20. Until here, is there any question? I think it's clear, right? You just multiply the probability and the payoff. Okay, the
We choose
is
the big order alternative here.
the big order alternative. The payoff in here is gain, okay, not cost. So the second step is to compute the EV for the chance node. Remember, you already have earlier what? 60 minus 40, 6, and 20, the EV. Now you compute the EV for the chance node. So in this case, you compute the EV, which is 0.6 times 100 and plus the 0.4, the probability, times minus 100. So you get 20 here for big order. Okay, for the small order chance node, in here you get 0.6 times minus 10, right? Plus 0.4 times 50. So you get 14. Then the expected value for ordering many fruits is 20. And the expected value for small order is 14. Until here, can you follow?
Yep.
Yeah.
No problem, right? So next, then you calculate the maximum EV for the decision node, okay? So in this case, remember the EV for big order is 20, the small order is 14. Now you maximize. In decision node, you maximize, okay? In chance node, you calculate the EV, but in decision node, you maximize. Why you maximize? Because your payoff is gain, not cost. If the payoff is cost, of course, you minimize. Okay. So here, maximum between 20 and 14 is 20. Okay. The last part is actually identify the best decision, which is simply marking the path. Okay. So you mark the path to see what is your decision. In this case, your decision is big order. Until here, is there any question? So you learn how to compute the expected value or the EV based on decision tree. So similarly, you can also use payoff matrix and then compute in Excel, right? So, oh, there finally, Michael Rodney is coming. Michael, why you are so late? Okay, so here you can compute the payoff matrix, okay, into the EV, similar to decision tree. Okay, so for your own practice now, okay, what is the best decision using maximum EV if the payoff matrix is as follows. So the probability in here is 0.5 and 0.5. It is Laplace. So anyone who can solve this, you can share your screen, and that will be your recitation for today, for this practice. Okay, I will wait for your share. So you compute, and once you finish, you share your screen for your recitation. So what is your decision?
Isn't it just any decision because both is 0?
Both are 0, correct. So in that case, you cannot decide.
Yeah.
Okay. So this is actually the weakness of, one of the weakness of EV. Okay. You cannot decide. Okay, next. This practice, the next practice is called Pascal wager. Is my screen. Okay. This problem was posted by Blaise Pascal. Okay. The probability that God exists is, of course, larger than 0. You can say very small or very big, is up to you, but it's positive. Okay. The non-existence of God have negative payoff. Okay. So if God does not exist, you will have negative payoff, say minus Z. Okay? Because you waste your time, you waste your energy or loyalty for your worship. Now, if you believe the existence of God and God actually exists, then your payoff is X. It is positive value. If you believe the existence of God, but God actually not exists, you have a payoff of negative Z. Okay? Z is positive, so negative Z is negative. Now, if you don't believe or non-believer, in case of God exists, then it will have infinite negative payoff, which is eternal damnation or hell. Now, if God does not exist, okay, and you don't believe, then your payoff is Y. So X and Y are some positive finite payoff. Now, question to you, can you compute the EMV or the expected value of better belief or non-belief? X, Y, Z are not given, but just telling that this is positive value. You can put any number. Okay. Again, you solve it and you can get a recitation point.
So we just put random number, or
It's up to you. You can put any number, or you can just compute using variable.
It's always better. Wait.
Which one is always better?
Wait. I guess it's always better to believe because non-belief is minus infinity, and yeah.
Yeah.
Yeah, I think the minus infinity is like the biggest part of deal breaker there.
Correct. Correct. So, right. Okay. So when you said believe, okay, no matter how small the assumption of positive probability of the existence of God, okay, the AMV of belief must be certain positive value, right? And the AMV of non-belief must be negative infinity. So in that case, your decision will be to believe, right? I mean, then you can say, look, believing God exists is actually a logical conclusion. Can you see it? Now, next problem, okay. Suppose Ali is an investor who invests, say, $100 either in safe asset, say like government bond, and bring 10%, which bring 10% return for 1 year, or alternative decision is he can invest in a risky asset, say stocks for a corporation, which bring 20% return, okay, if the company performance is good, or zero return if the company performance is bad. The question is, should he invest in stock or in bond? So based on this example, can you calculate? Can you try to calculate using
Wait, so is it like, isn't it the same? Because like
no
one is at 10%,
10% return in 1 year, right?
in 1 year.
Yeah, with this
And
100% probability.
yeah, but the other one is 20%, but like 50-50.
Right. So certain probability. You should assign certain probability.
So
You
so
probability that the company performance is good and certain probability that it will become zero.
yeah, so 0.5 and 0.5.
It's up to you.
Okay. So if it's 0.5 and 0.5, then wait. So you got 20%, and you get same, right? 10% and 10%. The other one is in 100. The bond is in 100% probability, and the stock is just in 0.5
And
probability.
0.5.
So which means you choose the bond, isn't it?
Yes. So can you share your screen of your computation so that everyone can see it?
Oh wait, I have to compute this. I'm just reading the text, sir. I'm just reading the PowerPoint in Moodle and answering your question. Hang on,
Yes.
wait. So should I make table like Abel did?
No, you can draw in your screen. That's fine.
Oh yes, screen. What is it? Can
And
I
then
draw on your screen? Is that
you can
okay?
draw in my screen. I can stop sharing and then you can draw on your screen.
Okay. So it's going to the
So what is this? Are you going to use payoff matrix or you are going to use decision tree?
I think I'm going to use the Payoff matrix, I guess.
Use matrix, you probably use Excel to compute, easier, faster.
Okay.
Decision tree you can draw. Anyone?
We have to know the probability, right, to make a decision.
Probability is subjective, so you assign probability on your own.
Oh, okay.
The bond is clear, so you can say 100% probability. But the stock is unclear.
Can I share screen?
Yes, yes, please. Lilian.
Okay, can you see it?
Yeah.
So the decision is the bond
If
with the EV 0.2.
decision is bond with EV 0.2, what is your probability?
So the probability for stock is 0.5 and 0.5,
Okay.
but the bond is 100%, so just 10%.
Okay.
Here,
All right.
no 0.1.
You need to take the average, isn't it? Not the sum.
Oh, the average of these two.
Correct, right?
Okay.
Probability multiplied by. No, the value with the 0.1 multiplied by 0.5 plus 0.1 multiplied by 0.5. So equal there.
Huh?
Okay, in E10, sorry, not that one, the E10.
Okay, E10.
Yes, so equal to C10 equal to C10 multiplied by C8 plus D10 multiplied by D8. Okay, so copy that.
So that's EV.
Correct. Yes, that one is E8. Okay, C8, correct. So in this case, equal. Your
Oh, they're equal.
yeah, they are equal. So at this point, if your probability is 0.5, 0.5, you cannot decide.
Yeah, so it must be larger or smaller than 0.5.
Yes, but remember the probability, it's you who assign,
Oh,
right? And this, of course, you assign based on certain information. Okay, so let me show my screen there. So in my case, I computed this way. So P is the probability that a good state occurring. Okay. For the bond, I put P multiplied by the capital, which is 100 plus the return is 10. So I get 110, right? So eventually I get 110. And for the stock, it is 20% possible increase of the return or zero return, right? So then I get 100 plus 20p, okay? So then we can compute the p, in this case is half. So if less than half, then you select bond. If larger than 0.5, you select stock. But if 0.5, you cannot decide. That's exactly what you did. So in your Excel, Lilian, can you change your probability?
Okay.
Okay, can you show again? Can you share? Right, so say you set one of them 0.6 or 0.55, it's up to you, okay. That one must be 1 minus the other one. Okay, correct, so 0.4. Then your decision is, y is still the same. Something is wrong with
Wait,
your,
this is the EV. I think I should change.
why your result still the same? 0.6 times 0.1, the sum is 0.1, that's strange.
Oh, it's okay. The bet decision should be the same, right? Because it's 100%.
The bad decision is 10% for that bond, right? Multiply by 0.5, right? In that case, the sum is just the sum because you already multiply by probability.
Okay.
Sum of that plus that, yeah, okay. I think you need to enlarge that so that you can enlarge the E, column E. And then
Wait. How can 10% times 0.4 results to 0?
Yeah, I'm wondering. I'm also wondering
Why?
about that.
Why
In
10%?
D10, yeah, D10. In D10,
The
the
bet,
D10.
formula that is D, the 2 delta D10.
Huh?
That one.
We use 0.4 times 10%. How come we get the result equal to 0?
Wait. Ah,
Oh, okay. So
Oh,
okay.
the same thing with that. Probably you need to change the decimal point in E. Okay. Can you compute that in the second row, the C and D11 is correct?
C and D is this time this.
Okay, correct. And then that one is correct. Okay, that one that now E11 is the sum, correct?
Yes, 11 is the sum.
Okay, okay. So in this case, if the probability of good is 0.6, then you can get stock will be your decision, correct? So in this case, you can use this decision you can use arc maps. So among the two, which one is the larger, and then you get it, so that you can automate the decision in Excel. Okay, you can use if.
sir,
Yes,
I want
please.
to confirm something about the chance.
Please.
I think you show us to make like an assumption without using the number, but using the like P, and the other one is 1 minus P. And after
Correct.
that, you get the conclusion. If the condition of the P is like this, then you need to blah, 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 blah. But if it's like this, then blah, 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 blah. So we cannot just like set the number of the probability as we like.
No.
We also need like the
You
steps.
can my answer there in the slide is more general, isn't it? I computed using simple algebra, but if you use Excel, you cannot use that. Then you need to set your probability, right? In fact, in the next topic of sensitivity analysis, you should be able to compute for all probability. So from 0, 0.1, 0.2, 0.3 until 1, 1, 0. What will be the decision?
Mm.
So in decision analysis, you should also compute the sensitivity analysis, meaning that what if your probability change from 0 until 1? What is the threshold that probability, say, at 0.5 or at 0.6, suddenly their decision will change from alternative 1 to alternative 2. Okay. So you need to compute the sensitivity analysis of your decision. Okay. Let me share my screen again. Can you see it? So in here I use P. Then we use simple algebra to compute the P. And then we can conclude, okay, easier because we generalize into P variable. Then you can say, okay, this is a positive, select stock or select bond based on the value of P. But if you use a computer, of course, you need to decide P first, right? Like what Lillian did. Now, there's a problem with this approach, you know. One problem is, of course, now at certain probability, you cannot decide because they are equal, right? And another problem is certain risk is higher, okay, if the probability to win is actually small. For example, in lottery, okay, in lottery, the probability to win lottery is very, very small, but the gain is very big, right? So with this approach, people irrational behavior, right? Why they still buy lottery, even though if you calculate EV, that is irrational to buy lottery. Okay, and this kind of irrational behavior is solved, yeah, later in utility analysis. Nah? Okay, so now because all of you are already here, my question to you, can you start to present your group project for a while?
Okay.
Okay. So we have 3 groups here, Bright Night, Power Puff, and Holistics. And then now I want you to present, and then at the same point, you also evaluate, and then you put your evaluation in Moodle in the second review. When you go to Moodle, okay, there is an assignment of second review. Then each of you will provide the review for each group, similar to last time. Okay. Is it okay with that? So that,
Yeah.
right. So if you're okay, so please present. So who first? Okay, Bright Night first.
Oh, that's us. Okay. Sure.
No problem.
Lillian, are you there?
Yep, I'm here.
Okay.
So you can share your screen. You can. Okay. The time is yours.
Let me get the files. Can you see my screen?
Okay.
Okay, good morning, everyone. Good morning, Mr. Teknomo. We the bright nights, and we chose the topic of um, optimizing, or to be exact, minimizing the waiting time for passengers of Surabaya bus. So
Minimizing.
Surabaya bus reimagined. This is the title that I have in mind. Like reimagined, like how the how can we fix and how can we improve to reduce the waiting time for passengers. Okay, that's the abstract. This study was brought up to support the public transportation advancement in Surabaya. The government has launched Surabaya Bus, expected to reduce traffic congestion and carbon monoxide pollution. Apparently, still fails to get a glorious welcome from public. Instead, people are complaining about the waiting time and complicated ticket buying procedure. Okay. So this is our main objective. We focused on one thing, which is minimizing passenger waiting time.
Okay.
And
Before that, what is the? Do you want to minimizing in all stops, including in the terminal, or only in certain location?
yes, for that one, I think we haven't decided yet because we have to choose from 3 lines, and in those 3 lines of in these 3 lines they have like multiple stops, and like yeah, I don't we haven't decided yet which line we are going to improve, or are we going to improve all of the 3 lines, or just one line at first and then we can proceed into the next in the future. I don't we still haven't decided yet,
Okay, so proceed.
but I think it is in a short amount of time. I think optimizing minimizing waiting time in one line is, I think, is already um, quite okay, rather than like trying to improve 3 lines all the same all together, but not having the maximum result. But I don't know, we will try like to improve all the 3 lines in Surabaya.
What do you mean by 3 lines? What are the lines?
Oh, the Surabaya bus has like from
Route, you mean route?
yeah, route. I mean routes. Yeah, with lines I meant routes.
Okay.
So they have from north to south, and then east to west, I guess. Wait, let me check first on my. Oh my gosh.
Yes, they have 3 routes.
Okay, 3 routes.
First one is from Terminal Purabaya to Rajawali. The second
Mhm.
one is from Une 1 ITS, and the third one is from Kenjeran Park to Gunung Anyar.
Okay.
Yep, as you can see on. Can you see my screen?
Yeah.
Yep. These are the
3 routes.
the 3 routes. Utara, Selatan, Barat, Timur, and I don't know why
Maybe because the return, they are actually the same route, but the return is different route.
I think yeah, I think so, yeah.
Mm.
Because yeah, okay. So yep.
Just wrong in the table. They are
Mm.
in the same. It's just problem in the typing of the table. They are actually the same.
Yep.
Okay.
Okay. So those are the three routes, and okay, back to this. So I guess this is the data that we have.
For the three routes,
Yeah.
bus for the three routes.
I'm sorry, sir.
This is per route is 20 bus or three route 20 buses.
I think the whole existing bus is
The
20.
whole city of 7 million people is only 20 buses.
I think so. That's what
This
that's
is
the
a
data
joke.
that I have. No,
This is a joke, right?
no wonder.
Actually, it's true. It's true. It is actually completely true. 18 to 20 buses.
20 buses for three routes.
Yes.
Yes, yes.
I
That's
divide by
why.
three, that means only 6 buses per route.
I think it's less than that because the east to west route only 4 buses are running.
So this
at
is a
time.
joke.
Yes, sir. That's why.
7 million, correct? What is the population of Surabaya?
Around 3 million or something.
3 million. Okay, you have 3 million population. Not 7. Let me check. Surabaya population.
It's only in the center of the Surabaya actual city, not the metropolitan area, I think. So
3 million. Okay. So 3 million and you have only 20 buses.
Yes.
That's a joke. But anyway, it's for a class problem that is okay. But I mean, for the city itself, it's a joke. It's not real.
Yeah.
Of 3 million population, even a portion of it, say 10% of it, right, will use pass. That means 300,000 people will use pass. Can you use 300,000 with only 20 bus?
I don't think so.
Yeah, it's impossible. Even if, and then what is the headway?
The what?
Headway.
Headway.
Headway mean from one bus, okay, they launch, right? The next bus, how many minutes?
Oh, the waiting time from one bus to
No,
another.
headway. Waiting time is representing the waiting time of the passenger, right? The headway is the supply.
The time between one bus to another bus.
Correct.
One bus to the next bus. So on the same route, right?
Minute. Huh?
So on the same route from one bus to another bus, right? That's what you asked.
Yes.
I have no data about that. I have not found any data. I have never tried to ride this bus actually.
Oh, that's sad. You need.
Yeah, I think I have to.
So I did once. Okay, it was very nice bus, but you need to pay using I think
bottles.
right.
Yes,
Plastic
bottles.
Yes. So and you need to have a certain number of PET bottle for payment, and then you need to collect a certain stamp. Right. And it is also not available anywhere, only certain location.
Yes.
Right. So I do have. Thank you.
So like maybe I need to go to a stop, for example, the one near my house, and then I just count from one bus to the next bus to get the.
That's fine. Or you can,
okay.
you can ask. You can call the agency, and then you prepare your questionnaire survey.
I don't think they have some kind of a hotline, because like even their website is just something like you know, it's not. I don't know. Abel, you use the app, right? What do you think about the app?
I
No, I
often
did not use app. So
use the bus, so I can say for with high certainty it's around 50 minutes or an hour if you miss
50
one.
minutes.
Yeah. Yeah. So yeah. I mean, Tribune can say that it's 30 minutes, but in reality, yeah.
That's it. Say you calculate. So you have 3 million population, right? So let's
Yes,
assume you have how many percent of that population will use bus?
like say 10%, like
Say 10%,
300,000.
that's 300,000.
Yes,
So if your headway is 30 minutes, so and then your bus, one bus is 60%. That means every 30 minutes you get only 60%. In 1 hour you get 120%. Correct?
correct.
So assuming they only ride one time, okay? That means how many passenger in one day? Your working hour is from 6 to 6.
But 6 to 10, 6 to
That
10,
means so 14 hours. Is that correct?
for 40. Not wait, from 6 to
Yeah, 6 to 6 is 12.
16 hours.
Okay, 16 hours. So 16 times
120.
times 60. So 16 times 120. How much is that?
800.
800.
Wait, 60 times
1,000,
16. Oh.
1,920.
Okay, so make it 2,000, right? Meaning that you can serve per route, nah? This one per route. 2,000 per route. Multiply by 3 route, correct? That means you only serve 6,000 passenger per day.
Out of 300,000. 300,000 people.
Yeah, that's definitely too small. Definitely
Yep.
too small.
But
It's
I
okay.
think,
For the class project, that is fine. So you can optimize. You can try to optimize.
but the thing that I think why this whole like public transport thing is not working in Surabaya, I think it's because like everyone here still love driving their own motorcycle and like their own vehicles.
That is demand and supply. For example, if you have a public transport, okay, it's not necessarily cheap, but more or less the same price as riding motorcycle, but it's available anywhere and it's only 2 minutes or 1 minute to wait. Question to you, will you willing to walk to the stops and use public transport or not?
I think if it's like, I think
1 minute. You
1 minute,
to wait
I'll
1 minute.
wait.
You will wait, right? So
Yeah.
if 3 minutes, are you going to wait?
3, yeah, I'm still considering it.
Okay, then you do a survey, okay, up to how many minutes
People are willing to wait.
willing to wait, and then up to how much people are willing to pay.
Okay.
And then now you compare the price and the waiting time, right? So then you can conclude how much is the waiting time per price or price per waiting time, right? So from there, they need to compromise between time and waiting time, right? Then how much? Once you know this number, we can use this for computation.
I see. Okay.
And then you also need to know the demand, right? So you can, okay, you can assume from the population, but say you survey 10 people and then ask their income, okay, per month or per year, and then asking them, are they willing to use pass? If the condition is this and this and that. I mean, the optimum condition that they want.
Okay.
Okay. From there, then you can start to think about how to optimize the, what is that, minimum waiting time and so on. And then you can also ask, what is the route?
Oh, okay.
Of course, they want a route that is near their house because meaning that they need to walk or they need to use bicycle. Okay. And the question is there any parking lot near the stop?
Okay.
Public transport, the main public transport like bus is main route. So there must be a feeder service from the home to the main hall.
There's one like I know one stop in like this the route from south to north, I think, or the from Gunung Anyar to Kenjeran. They have one stop that where they have one window parking lot, like the like the one that was built by the government. This hope.
Okay.
Yeah.
So public transport should serve from home to home, not just the main hall. Okay. That means you need to think of the whole system, not just the main hall.
I see. Okay.
Okay. So, and then tell me later on, what is your solution? And then how are you going to compute the optimization?
Okay, that one. Lilian, are you here?
Yes.
Do you
Right.
want to explain?
Oh, wait, actually, I have a question.
Please.
You said that when we do a survey, we must ask the passenger whether they want to pay
No,
extra.
not passenger, not passenger. Candidate or passenger, meaning your friend or your family member, that's fine. You can
Oh,
gather.
yes, candidate of passenger whether they want to pay extra for a better facility. But for this bus, it's free, right?
I know it's free, but when you compute, you compute based on the willingness to pay. Okay, WTP is willingness to pay. Point is free, right? So then you can calculate from how much? Say 15,000, that's $1, or 25,000, $2. Say 30,000 per ride. Okay, that's $2, right? And then you change by 3,000 or by 5,000, it's up to you. And then you plot. Okay, you ask them if this much, how much? If this much, how much is the waiting time that you want? That kind of data is what if scenario, not real. But it will help you to make a decision.
Okay.
Okay. So, of course, because this survey, this kind of survey is intensive, so you probably need to ask not so many people, just 20, 30 is okay. Just to get because you need to be there. Even if online, you need to make it online with them. You cannot just distribute questionnaire and ask them to fill up because they will not understand what you mean.
So what if I with like for this project, if I limit the respondents for like my like the university friends?
It's okay,
University
but make sure that they have a variation in terms of income. Okay.
Oh, wait, the income.
Yes, income level must be varied because if you only put into a uniform group of people, say Petra probably middle class and high, then the answer is almost the same, but you don't represent the whole population.
I see. Okay.
Okay. So it doesn't matter who, but the matter is the profile. So income level profile, socioeconomic background, that is the factor there.
Yes, sir. Okay.
Okay.
Thank
And
you.
we can later on with that, you can later on propose a new bus, not necessarily Surabaya bus. Okay, you can propose, for example, in here in the Philippines, I proposed last time a special bus which is for the rich, for the middle and high income level. So now they propose, they make it. Okay, so it's 100 pesos per ride. It is quite expensive. That is $2. But it's air
Oh,
conditioned with Wi-Fi. Okay, it's limited. It's very nice bus. You can check. So it's now operating already. Destination
so
spot,
the rich
certain
will
hotel.
ride buses now?
Yes, because bus is not necessarily for the poor, you know.
Yeah, I think so.
In fact, if you make the rich use bus, then they will not use car. Then the traffic will be better.
Yes.
Okay? The
Even
poor
better.
use bus is captive, meaning they have no choice. That is not improving the traffic at all. Improving the transportation, yes, but not improving the traffic.
Mm-hmm. Mm-hmm.
So
because the people who makes the traffic congestion worse are the people who can afford cars or
correct.
Yes.
Correct.
Yep.
So you need to save. This is called mode split. Okay, you need to save the people who use car, who use public transport. That's the main idea.
Mm-hmm.
But
Mm-hmm.
to be there, meaning that you need to provide certain convenience, certain comfort, certain security. Okay, because they are very sensitive to this kind of things, to the force, right? So that is the main idea. Providing for the poor, like the Surabaya bus, does not improve traffic congestion at all. It will improve the transportation for the poor, yes, but it doesn't improve traffic congestion.
So Abel, what do you think? Do you are you willing to pay for like
Later you can survey that.
$2 for a ride, Abel?
$2? Oh,
Yeah.
God.
Why?
Why not just pick a Grab then if it's $2? I can grab a Gojek or a Grab for that price.
$2. Probably the income level is different from Surabaya and here. So here, when you it's like $5.
Hmm.
But in Surabaya, probably around $2, right? 30,000, right? Per meal.
Per mile?
Per
I
meal.
think it's only $1.50, right?
Really?
$1. Yeah.
Per meal in restaurant?
Hello, everybody else?
I don't know, man.
When you buy food, how much is per meal?
Per,
Oh,
Per
per
meal?
meal. Per meal.
per
Around
meal?
like
Yeah,
15.
$2.
$2, correct.
Oh,
Yeah,
So
$2.
in here is about $5.
Ah, I see. Okay.
Okay. So $2 is like less than half of the per meal. Then in that case, you probably willing to pay up to $1, isn't it?
yeah, I would pay that much.
Right. So more or less the same. Okay, so is there anything you want to present? This group? Right.
Wait, Lilian, I think Lilian will present the next slide. Hang on.
Okay, please.
Lilian, okay.
Okay, so this is the formulation
Okay,
because
okay. This is the
we use your formula.
yeah, you can use. Actually, not only you use, many people use this, so no problem.
Okay. So yeah, I think this is gonna be our formulation to solve the problem.
Yeah, this is simple logic of the units,
Mhm.
Yeah. So you need to know the distance in this case, right? One cycle.
Yeah.
Okay, you calculate the distance.
Mhm.
And then next, how do you optimize? In here, I did not put optimization.
Now that part is yes, that's the part that we forgot to ask you. I think
So you need to formulate.
yeah, for this, to be honest, I still have no clue whatsoever how to optimize the what we're how to um
So based on your uh, course, okay, so you think in terms of decision,
mhm,
and think in terms of decision based on individual decision or based on the crowd decision, group decision. Later.
okay.
Okay. So then similar to today's class, so you can see, for example, you want to put the gain and cost and certain probability, for example.
Okay.
Okay, so
So
use what we have learned in the class and then you can start to improve.
okay. So if regarding to the previous class, then we probably the calculations will be around like the max and the thing, right?
That part is the beginning, so I don't think you will use that for this kind of problem because you're supposed to know the probability at this point.
Yeah. So it means that today's material is considered can be considered for decision making in this.
Can be. Later on, you can also, if you want to use the network, later on you can use the more advanced materials. When we discuss IFN and maximum entropy and
Okay.
programming, so you can also use that later on. No problem.
Okay.
At this
I think
point,
yeah.
just basic formulation of your real problem, and that's enough. But as we grow, learning together in this,
Mhm.
you can start to include all those things.
Yes, sir. Yeah, that's okay. I didn't know that we should have used like the materials. Yeah, yeah. I'm sorry.
Yeah. So actually, all the slides I posted in Moodle already. If you have time, you can start to,
Okay.
and you can check which one is fit into your problem.
Okay. Yes, sir. I will update you with like in the next
Yeah, in the
presentation.
next presentation. Okay.
Yes, sir.
I don't know
I
when is
will.
that. April? Is it April? Or
I think it's on April.
okay. Okay. Good.
Okay.
Good then. Or
Thank you.
you have something that you want to present.
I know. No, this is the last slide.
Okay. Okay. Good.
Thank you, sir.
Thank you. After B is H, so holistic. You want to share your slide? Darwin and Stephen, right?
Wait,
Okay.
okay, so I want to present about micro project.
Mm-hmm. Choose. Okay, production. Explain.
Wait, sir.
Okay, you can show your video so that you can see that only me who. So I will stop my phone. You can show your own video.
Okay, okay. So the background is the production of the shoes in Indonesia is still.
Mhm.
Hello, sir.
Yes, please. Go ahead.
So the production of the shoes in Indonesia is still low. So we want to increase the production of, so we can make the price of the shoes cheaper and we can
Mhm.
compete with the other products.
Okay.
The quarter is one shift work is equal to 8 hours and
Mhm.
one shoes for each station is equal to 1 minute.
Okay.
And there is 8 stations like the stitching and then cut the material and then
Mhm.
glue the shoes, quality
Mhm.
control, and any others.
Okay.
And the cost of labor in Surabaya, if I'm
Mm.
not mistaken, is about 4.3 million Indonesian
Yeah,
rupiah.
that is the minimum wage.
Yeah, and the material of each shoes average is about 100,000. And there is many other costs like the water and then the glue and maybe the electricity and many other else.
Mhm.
And this is my formula is x is equal h divided by t. X is the total shoes we can produce in each day and the
Mhm.
X is the total hour of worker in 1 day and the T
Mhm.
is the total time each station of making a one shoes.
Okay.
And we can know in 1 month the product
1 day.
1 day is 60 pieces and 1 month if I calculate it in the worker like 1 week only 40 hours so only 4 days like that. So 1 month is 4 weeks, 1 month 4 weeks, so 1 week equal to 5 days of work. So 60
Okay.
times 20 is equal 1,200 pieces of shoes.
Okay. So, can you actually put the units and the meaning of each variable?
Okay, I will add it
Okay.
later.
And okay, next, what is that all?
Yeah,
Optimization
I
then.
have
What do you
more,
want to optimize?
maybe to make less the stations so its worker can be more productive like after they cut the material they start to stitch it like that so from each station to each station more less transportation I think like that.
Okay, so in that case, can you draw later on? You have 8 stations, right?
Yeah,
Okay, can you draw the drawing of each station and then can you gather the data for each station? How many seconds per station and how many worker per station?
okay,
Okay, so at this point, your data is not enough to compute any optimization because you need to know what is the capacity for each station,
yeah,
right?
Yeah, yeah.
And how many workers and how many costs, how many effort.
Okay.
Knowing the detail, then you can start to play with the optimization. But when you go into very general like this, so you cannot do optimization because you need to go into the detail.
Okay, sir.
For each station. And the question is from one station, can go directly to the next station, or is it in sequence? Arrangement of the station, and then from one station to the next, how long? What is the transport cost there? Say
Okay.
1 minute, 1 second, or 30 minutes from one station to the next. Are they waiting for one bus before they move to the next station, or actually per they will go to the next station? So we need to know the detail in the factory, right? Then you need to explain more detail than this.
Maybe Stephen can add that.
Yeah, I've already read it, all that you say, sir.
So you can take certain video in the station so that we can have imagination what actually you are trying to optimize here. Next, I would like to know about the BEP, break-even point. Do you know how to compute?
Like the before.
No, BEP is like what is the variable cost and what is the fixed cost there? What will be the zero profit to compute? You haven't learned about BEP, break-even point?
Oh yeah, in semester 3.
So you learn already. So can you use that knowledge for this project?
I will add it.
Okay. And can you also add the real decision that your company need to make? Right. What is the allocation of resources? How many material or what? Something that you have learned in OR1, can you apply it here?
Okay.
Then we will improve it later on. You learn in this course. Okay. At least the basics should be there. Something that you have learned in the past few semesters in college. So you need to use all of those. Right? Can we expect that to happen in the next one presentation?
Okay, I will.
Okay.
I'll stop share, yeah, sir.
Yes, please. Okay. So, okay, go with the next presentation then. Power Path, Michael, Eugene, and Abel.
Okay, good.
Okay. Abel, are you there?
Yes, yes, I'm here.
Okay.
I was just grading holistics.
Okay, I'll do the opening. Okay. So, good
Yes.
morning, everyone. Good morning,
Good morning.
Mr. Teknomo.
Yes.
So today, this is our project presentation. This is the second time, and it's me, Eugene, with Rodney and Abel. Let's start it. Next slide, Rodney.
Okay.
Okay, so first, we're gonna talk about the novelty of this project. So the solution, this alternative, was made in order to eliminate the time wasted on the flight and reduce the inefficiency of a flight travel system. So, what we wish that this project can either make people achieve their destination within more favorable time, or they can traveling through an efficient distance with a decent payment of price. Okay, next. As you can see, the focus is really simple. So minimizing the time wasted on the plane
Inside the
by
Yep, inside the plane, as in travel distance, basically travel distance and travel time.
Okay, travel time.
Distance, I guess, translates to time, so it's distance.
Okay.
Okay, next. And this is the our calculation for the system that we want to build. This part
So-
will be handled by Abel. Please, Abel.
Okay, so I looked up all the distances between the cities, and I chose these cities. These are all the distances in kilometers. And could you go to the next slide?
Can we change this one?
Can we change?
Yes. Can you,
Uh,
instead of international, can you make it into national?
I think national for Indonesia, the flights will be painful, as in
Why?
like we don't have direct flights from like Papuan cities to other
That's exactly the nice problem to handle, isn't it?
I guess we can change it. Yeah.
Because all the cities that you put here are all hubs. This
Yes.
is a simple problem. You can solve it within a few minutes. This is not a project anymore. It's a class project or class practice only. But for a group project, that 60% of your class grade will be. So you should have two type of problem. One is handling the hubs.
I see. So should we mix in non-hubs then instead of the...
non-hubs. So say I want to go from Jayapura to Medan, right? So you know the hubs are probably Surabaya or Jakarta, right?
Okay.
Or probably somewhere else, I don't know. So then you know the hubs, then they need to go certain hubs first before going to different places. Then that is the one that you need to optimize in minimum time.
So I think with that way, I think we should reduce the amount of cities we have because
it's okay. You can reduce the amount of cities, but you need to have both hub and non-hub. And I hope you can at least put the amount of cities can be for each island. I mean, the big main island. 5
okay. So national then, region, domestic flights then.
domestic flight for each
Yeah.
island, okay?
Yeah, it's fine. Okay.
Not 17,000 islands. Only Sumatra, 1 or 2.
Yeah.
Okay, Java, or maybe 3 or 4 like that. Okay, Kalimantan, 1 or 2. That's fine.
Oh, okay.
Okay. Bali is a hub, so you probably want to put it there.
Okay.
Yep.
So this is not going to be useful then.
Yep.
This is international. The one that you put is all hub, so that's too simple.
Okay.
I mean, Rio and Auckland and Cape Town aren't hubs, but
All
I guess
hubs.
it's
The one that you send, all hubs.
okay. Yeah.
Okay.
Right.
So this is the direction that we were meant to do. So
Can we change the term plane here to be flight?
oh, okay.
Flight, right?
Okay. Okay.
Can you also add, for example, the waiting time in the airport because of the change of plane?
So you include the waiting time on the
assume that. You can assume that. Okay, you can put 1 hour or 2 hours. It's up to you. And then, of course, you also want to minimize the number of changing plane, isn't it?
Minimize the number of changing. Oh, so the time then you don't take your stuff and put it on another plane.
Yeah,
So just one
the
plane.
number of stops. You want to reduce the
Oh,
number of stops.
oh, okay. Okay.
Okay.
Okay,
Okay.
that will be a nice problem.
Okay. Okay. So this is the part when we don't understand the robustness of the system. So this one is it
Later,
the
when you do sensitivity analysis.
oh
Hmm.
so okay, but I don't think we got this yet, right?
Okay, okay.
Okay. So this is the limitation. So I think the limitation is still work, right?
Okay, no problem. Straight line is fine. No problem with that. The things that you don't know, you can assume that is fine also.
Okay.
Okay.
Okay. So
So I guess you start to think in terms of optimization. Okay, what is the optimum of what do you want to optimize? What are the constraints?
okay.
Okay, and yeah, those are the constraints. Probably I can think of probably the number of stops, right?
Okay. And the weight on the what on the airport, right?
Airport what?
With the wait time on the airport.
Waiting time, yeah.
Yeah. Okay.
That's also include then because that is actually correlated to the number of stops, so that's super easy.
Okay.
Oh, so we'll be taught how to solve that during this class, right?
You will be, not me.
Yeah.
Hmm.
Okay.
Okay.
Okay. So I think that's it. Yeah.
Okay. Now I want to you because this is a so I want you to ask each other. So anyone can ask any other groups because you will evaluate them anyway, right?
Yep.
Okay. Go ahead.
Oh, it's a Q&A session now.
Yes,
Okay.
Q&A session now.
Please, I will wait for questions, Abel.
Well, you can
Oh,
question others also.
I expect questions from Abel and Eugene and Rodney. Or any ideas, guys? Come on.
Actually, Nyoto, do you want to like instead of optimizing on those 3 routes, why don't you think about making new routes instead?
Yeah, that's good suggestion.
Okay, thank you. I will try to consider that. Okay.
Try to consider that. Okay.
No, yeah, I will consider that. Not try consider that. Yeah, my poor choice of words. My bad. All right, thank you for the suggestion. And yeah, I think for your group, I don't have the correct question or any suggestion because like I don't really get what you're trying to do there, like domestic flights and stuff.
Oh, it's the same like
The same like yours, but on the sky.
I see. Okay, same like okay.
same like your
It
bus actually, right?
yeah. It doesn't deviate much from your bus, I think.
Yeah, it's yeah, I think so. It's basically we all of us are trying to
Yeah, maximize
improve
something.
our
Yeah.
transportation system in Indonesia. Yeah.
Yeah. So in the bus you have terminal, so that is the hub, right?
I'm sorry.
In the bus system you have terminal, that is the hub. And
Oh, okay.
the
And
small.
these cities are the hub for the planes.
Yeah. The network
Oh,
type, but similar problem.
I see.
I did not
Okay.
see anyone want to give suggestion or comments or question to Darin and Stephen? Do you-
I don't actually quite understand what they're trying to make.
Oh, Darren and Stephen, can you explain again so that they will understand? Otherwise, they will be low grade.
I'm confused. Like they have calculations and they're just calculating the number of shoes produced in a month.
Exactly.
That's what.
That is not clear, Darren. Stephen, can you explain more detail? What do you want to do? What is the optimization here? Stephen, yeah. Are you still there?
Hello, sir.
Yes, please.
Yeah, we want to increase the production like from 1,200 become 1,500 like that.
No, we want to know what do you want to optimize?
Yeah, like how the worker make the shoes, or we change the worker with the machine like that.
I'm
It's
sorry,
too
but I think
general.
in my opinion, if you try to optimize it that way, then it's not like I think it's more related to the other course. I think if we go back to one semester previously, and it's related to what was that? APK, APK with
Motion time study, right?
yeah, motion time study. I guess if you trying to optimize the
A person,
worker,
right?
you
Yeah,
try
yeah.
that's
That's fine. If you want to do a motion type study, that's fine. The
I
question,
think.
what you are doing is not yet there, right?
Yeah, I think so.
So if you want to have motion time study, then you need to know what is the motion, right?
Yes.
So you need to know each station, what is the capacity of production per station, what is the, and then how we'll move from one station to the next, right?
Yeah, but I think last week they said that they have the connection, right? They have something. So I expect that this week they cut the video or something. Yeah. So
Yeah. So, Darren, Stephen, can you improve a lot, huh?
Okay, sir. I think I will add what you say last time about the station.
Mm-hmm. If you need to consult with me, you can consult with me out of the outside the class. That's fine. Okay.
Oh, yeah.
Okay.
Oh, do we have your phone number so we can
I
actually
think
ask?
so. In the course syllabus, I put everything.
Oh, okay.
Okay. So, yeah.
So, how about we do like international non-hubs then, rather than
Oh, that's fine also.
yeah.
But why? The
'Cause
question is why?
I
What
don't
motivates
know.
you?
I don't
What
know
motivates you?
because I want to do that in the future.
Ah,
I want to do that.
what I'm thinking is, this is just my thought, huh? So if you cannot solve your own problem internally within your nation, why you want to solve international, which have more rules, more complicated things?
Because
Abel hates Indonesia.
yeah, honestly, I couldn't care less about going to the other islands, but if it's other countries, yeah, I'm in the bigger
the
mood.
same, it's just name of cities. I mean, in terms of data, right? In terms of data, you have you measure by Google, and then you measure the flight distance. It's easy, right? You get Google Map, you just measure it 2 points, you get the kilometer.
Yeah.
Right? and then you know the for each airport, which are the hubs in Indonesia, and then you put it in. Anyway, this is suggestion. It's up to you. If you want international, then actually much more complicated than in national. You know?
Yeah, I guess I'll discuss it with Eugene and Rodney.
Okay, okay. Okay, so
Sorry, Mr. Teknomo, can I ask a question?
please, please.
Like for the robustness of the system, what are we supposed to? How are
So
we supposed to compare?
say, for example, if the probability or certain parameter change.
I saw the one publication on I tried to find what's the robustness, and then I read one of your publications about robustness of that's not the same robustness, isn't it? Like the
It's the
robustness
same.
of
For example, different. The one that I published last time was in case of bombing, right? So if there is a bomb in certain city and the node was destroyed or the link was destroyed,
yeah, that one.
it will destroy the whole city or not? And
Yes.
that. So in that case, it's different type of robustness. In your
Okay.
is not destroyed. So we just want to know, for example, if there is a disturbance, okay, there is a disturbance that will change certain parameter in your formula. For example, probability. Oh, like a while ago, we just discussed last hour. The probability is P equals 0.5, then you cannot decide. If the probability is less than, you use Ox, right? And the probability you select what, the band or something. So kind of robustness, meaning that you select the parameter inside your system, then you want to know what is the parameter value that actually can change your decision.
I see. Okay.
Right. So one parameter is probability. The other one is actually depends on what parameter you want to set up.
Okay.
Okay. And we, of course, you want to know later on which parameter is the most sensitive. Sensitive mean, yeah. If you change a little, for example, your input change a little, okay, then the output will be the greatest.
Okay.
Okay. So this is an optimization within your system.
I see. Okay, sir.
Okay.
Yep.
Okay. So you want to have a 5-minute breaks. Now is your time. I think it's 10:30, isn't it?
Yes.
Okay.
Yes, sir.
And 10:35. Is it okay? Then we will continue the next topic. What is the next topic?
Can we get more time for like the what is it, rating?
Yeah. Rating you can do it after the class. No, that's okay.
Oh, okay then.
Until tonight, 11 o'clock, right?
Oh, okay. All right. After class then. Okay, 10:35 sounds good. Or yeah.
So can you refresh Moodle? I just uploaded the value of information there. We will discuss that. Okay, 5 minutes break. Okay, can be back now. Are you all there?
Yes, sir. I'm here.
Everyone? Michael?
Yes, sir.
Lillian? Eugene? Abel? Are you there?
Yes.
Okay, so shall we start again? Okay, so I'll share my screen, which is value of information. So this is the continuation of decision 3 a while ago. Okay. So you remember we discussed about decision under uncertainty and the risk. Okay. Okay. So we need to discuss a little bit about Bayesian. My question to you: did you take statistics? Oh.
Yes.
So you know how to compute Bayes theorem, Bayesian?
Uh, I think I
No.
forgot about the.
I forgot already.
You forgot or you don't know? Okay.
Isn't it? We got it from statistic.
Okay. In statistics, what did you learn?
I think. Wait. Wait. Let me see first on.
We learned this in the first semester, I guess. But
Okay, so
for
you know Bayes theorem, right? You know Bayes theorem.
I've heard of Bayes theorem before.
Okay,
I'm
you've
sure
heard of
I've heard of it.
Sure you heard. Then it's fine. If you don't know anything, then I need to repeat that part. That's my point. Okay. Anyway, let's continue. So this is what our topic is today, and you will learn about risk profile and value of information. Okay, and this is repeating what we have discussed earlier. So we have decision under uncertainty. We have decision under, right? So, and now in risk analysis, okay, you will study the possible payoff and the possible probabilities, okay, associated with the decision alternative or a decision strategy. Okay. So in this case, you will create what is called risk profile, and then you will do sensitivity analysis. So this is where the robustness comes from. Okay, robustness of your system. So what is risk profile? Risk profile is a chart. So it's a chart to show the probability distribution of the possible payoff associated with a decision alternative or decision strategy. So the purpose of risk profile is to compare the change of distribution. Okay. When you use risk profile, of course, what you use is only the risk profile of optimum decision. Okay. So in this example, I give you on the left side is the risk profile of the fruit store problem. And then later on, because of the certain marketing study, the risk profile will change. Okay, let's go into the detail. So this is the fruit store problem. So I will show you. You have a fruit store problem earlier, right? You have big order, small order, high demand, low demand, correct? And the probability is 0.6 for high demand and 0.4 for low demand, correct? So then you plot, you can plot this. So 0.6, can you see it? So you have 0.6 here. Oops. So 0.6 for, what is the value of 0.6? It is 100, right? So you have 0.6 and 100. So you get the bar, and you get for big order. Huh? For low demand, you have 0.4 and negative. So you have 0.4 and negative 100. Sorry, negative 100. So this is the risk profile for big order. Similarly, you can also draw for small order. Risk profile for small order with the 0.6. The gain is negative 10 and low demand is 50 for the payoff. So on the horizontal axis, you get the payoff on, in this case, the gain. And then in the vertical axis is the probability. Now my question to you, can you draw the risk profile of certain decision? Anyone? Do you get the meaning of risk profile here? Risk profile is just a chart, okay? A chart between the payoff and the probability. Can you get it? Okay, for your practice, give me the risk profile of small order. Can you draw it or not? Anyone who want to share the screen?
I would like to try.
Okay.
So
Risk profile for small order.
that's still in the same PowerPoint, right? Or
No, in the value of information.
value of information.
Yes. The PowerPoint changed to value of information.
Okay.
Did you
So-
refresh Moodle? If you refresh Moodle, you can get that value of information slide.
Wait.
Okay, the answer is not in the slide, so anyone who want to share the screen? You draw simple using your whiteboard.
So the number was, wait.
Minus what?
10
Minus 10 and 50, right?
and 50.
Yes, and then you draw. 0.6 is minus 10. And then 50 is 0.4.
0.
Or you can use Excel to draw that. Then
This one 0. Let's go 0.4. So this one goes here. This one goes here.
Can you share it so that we can all see?
Wait, you're not seeing my screen, not my
No,
whiteboard.
I cannot see your screen yet.
What? Wait.
Oh, there.
Still.
Okay. Okay, good. So 0.4, right? 50. Yes. Okay. Very good. Yes. Very good. Very good. So that is your risk profile for small order, right?
Yes.
Okay. Very good. Okay. Let me share my screen now. Now, suppose you get a new information. Okay. suppose you have a new information, what is called market study. A while ago, you did a fruit store problem without market study, right? Okay, you just assume something, correct? So now suppose you have a new information, what is called market study. So you have a survey. So you hire a consultant, okay? And you know that the probability of high demand is 0.6, right? Can you see this slide? And the probability of low demand is 0.4, right? That is the likelihood. No, that is the prior, okay? And then now, suppose you have the market study that states that if your the probability of high demand is correct, okay, will be 90%. Okay. The likelihood that it is high demand and it is incorrect in your market study is only 0.1%. But if it is low demand, apparently the market study cannot do well. So the probability of incorrect in low demand is 0.8 and the probability of correct in low demand is only 0.2. Of course, the sum of probability is 1. Then, based on that, you can calculate, okay, the joint probability. Okay, the joint probability you can calculate based on the prior multiplied by the likelihood. For example, in the market study, you have state of nature is correct and high demand. You get 0.54 there from where it is. That is from the high demand, which is 0.6 multiplied by 0.9. Okay, so I will make the pen. So this 0.6 multiplied by 0.9, it will give you the 0.54. Can you get this or not? So similarly, the other numbers, 0.6 multiplied by 0.1 is 0.06, right? Okay. So then you can calculate what is called posterior probability. What is posterior probability? Posterior probability is based on Bayes theorem. Okay, so in this case, okay, look at this number. I want to make so that the sum of probability in the column is 1. Okay, so in this case, what you will do? What you will do is you divide. Okay, I will make a new color here. For example, I will make blue. So you divide, first you sum this. For each column, you sum. Okay, so 0.54 plus 0.08 is 0.62, right? So you sum this in each column, and then now you divide, okay? You divide 0.54 divided by 0.62. Then you get that 0.87. Can you calculate this or not? Similarly, in here, you have 0.06 plus 0.32, you become it becomes 0.38, right? Then you divide 0.06 divided by 0.38, you get 0.16. So by doing so, you will have each column here, the sum is 1. This probability, the pink probability, 0.87, 0.16, 0.13, and 0.184, this is called posterior probability. Until here, is there any question? So First, you get the joint probability. After that, you calculate the posterior probability. Okay. So once you get that, now we can include everything here. Okay, we can include everything here. So look at this. A while ago, we have no study, okay, in the slide of decision under risk. We already include this, right? We have this no study in the decision under risk. Now we have the market study. Okay. Now we have, what is the value? 0.62 and 0.38 here. The sum of joint probability. Can you see this? Okay. So that will be included here. And then now you have a new value of this EV and the risk profile. Okay. Then you can calculate the risk profile here. So I computed here, you see if the market study is correct or incorrect. The market study is correct, the probability is 0.62 based on that table, right? You see this? And then now you also use the posterior probability. Okay, this is the posterior probability. Can you see it or not? This is the sum of this is the sum of joint probability. Okay, on the left is the sum of joint probability. On the right side is the posterior probability. Based on this, now you can calculate a new one. You can also put the risk profile here. You see, 0.87 is 100, right? And then 0.13 is negative 100. Again, you have this is the risk profile, okay, of your optimum decision. The optimum decision is the one that the part is in bold, meaning that if your computation, if you have market study and your result is, your market study is correct, you will select big order. If you have market study and your result is actually incorrect, you will select small order. So both of them are optimum decision. Can you get it? Then you calculate that and then you include in your risk profile. Now based on the risk profile, you can see the risk profile change, right? Earlier, we have without market study, this is your risk profile. Okay. Now with market study, now you have this risk profile. What is the meaning? Meaning that now you distributed. The market study actually improve your decision because now your probability distribution is distributed. Can you get it or not? The next technique is called sensitivity analysis. Okay, so in here you study how the change in probability, okay, for the state of nature and the change of payoff will affect the recommendation of decision alternative. So the technique is rather simple. For you treat one of the probabilities of the state of nature as a parameter. Then you calculate the expected value for in terms of that parameter. Of course, the total probability must be 1. Then you get the range of probability for each alternative by maximizing the expected value. In this case, because we use gain as the payoff. Okay, let's take example. Okay, so in the fruit problem, suppose you copy the high demand, high order, and low order. Okay, and then now you set up the probability of high demand from 0 to 1 with increment of 0.1. Okay. Earlier, the high demand is, what is the probability? You remember? 0.6, right? So now, instead of 0.6, now you make a range of probability here. So from 0 to 1. Okay? Then in Excel, you can use data and then what if analysis and do data table to get everything. So what will happen if you use a big order or you use small order? Okay. And from there, you can compute the result and you can draw the sensitivity analysis. So in this case, if the probability is less than 0.5, okay, you will decide small order. If the probability of high demand is larger than 0.5, you will decide big order. Up to here, any question? Is there any question? Can you grab it or not? So I can show you what I did in Excel. So here, without market study, okay, this is what I did. So I just put the probability 0.6 and 0.4, right? And this is the risk profile, right? The risk profile represents the optimum result of your decision making. Now, if you do a with market study based on optimum decision, you will have this result: 100, okay, minus 100, minus 10, and 50. And these are the probability. This probability coming from here. So this is your result, right? The payoff. And then if you have, this is the one in yellow is the one that you input. Okay. Because of your market study, you have a correct result or incorrect result. Then you can calculate that. Okay. What is the expected value? If you have imperfect information, okay, then what is the computation? Here is the posterior probability I showed you a while ago in the slide. Okay, and from there, you can actually compute the risk profile. It is based on the posterior probability. And then you can plot that risk profile. Okay.
Oh, it's the same with what I did, right?
Yeah, the same what you did a while ago, but now you have a additional complication because of the market study, right?
Oh, okay. Yep, yep, yep.
Okay. So now you need to put this probability inside. Okay. So my point is, a while ago, you have here. Maybe I should share this. You see, earlier you have only no study, right?
Yes.
Okay. Now you have market study that complicate the matters, right? So
Oh,
now you have all this probability inside that you need to compute.
okay.
Okay.
Yes.
Then based on that computation is the one that you put into risk profile here.
Oh, okay. Yeah, I see.
Okay. So
Yes, sir. Thank you.
can you get it? So
Yeah.
this,
Okay.
now based on this risk profile again, now I come back. Okay. Without in this sensitivity analysis, I do it without risk profile. So in this case, I use the original fruit store problem. So let me share. Okay. In the original fruit store problem, you have this 0.6 of high demand, right? Originally. Then what you need to do is you will calculate, okay, what will be the value, okay, for probability 0, 0.1, 0.2, 0.3, and so on, okay, based on this table. This table. Can you see it? The table of payoff matrix of fruit store problem. Okay. So in the fruit store problem, you see here, you already did this earlier, right? So if the value is what? I compute the big order, which is 100 times 0.6. Can you see it or not? And for low demand, I computed minus 100 times 0.4, right? And then the decision here, you use if, right? If this value of the alternative is larger than big order alternative is larger than small order, then use big order. Otherwise, use small order. If they are equal, then you put question mark. We don't know. And then get the AV, which is the expected value, which is the maximum of that sum, right? So you get the EV and you get the decision. Now you put this value into the sensitivity analysis. Okay. What will happen if I have big order? What will happen if I have small order? Okay. You can use this. What is this? In Excel, there is a technique called data table here. Okay. So you can use this to compute the internal value of your sensitivity analysis. Okay. Then you can get, from here you just simply get what is the order. Is it small order or big order based on data table again of this decision. Can you see it or not? So then you can see here, okay, this is your table of sensitivity analysis. Then you can start to plot them. So actually the intersection is about 0.6. Okay. So here. Now, based on this sensitivity analysis, now you know, right, that if the value is less than this, you will select small order. If the value is larger than this point, you will select big order. So this is how sensitive your decision based on the probability of high demand. Up to here, you have any question? Do you have any question up to here? Is it clear? Okay, I will test it. Lillian, can you explain what you just learned?
About the sensitivity analysis.
Analysis and risk profile, yes, please.
I'm sorry.
Yes, sensitivity analysis and risk profile. What did you just learn?
Okay, for the sensitivity analysis, so if the so if the big order is larger than the small order, then we should select the big order.
Yes, but what is in the big picture? What is sensitivity analysis anyway?
Sensitivity analysis is analysis that we see from the probability. Yeah, from the P.
Okay, change one of the probability. Okay.
I'm sorry, what?
Means when you change, you vary. When you vary the value of probability. In earlier problem, we have probability is equal to 0.6.
Yes.
Right? But now what happens if we don't fix the value of 0.6, but we vary that from 0.1 or from 0 up to 1?
Then it'll change.
Yes, it will change. The decision will change, right? Then what is the change? This is what is called sensitivity analysis.
Yes.
So it's to measure how much differences, like how much changes is it going to happen, like the amount of changes that might happen, right?
Correct. Okay, so the value of the alternative here, it is the one that you will select. So the same thing, later on when you create your group project, you will, okay? So
I'm sorry, I didn't catch.
When you do a group project, you will also plot your sensitivity analysis.
Oh, for the robustness.
Correct. Also for your risk profile, you will also do it.
Okay. Yes, sir. We will try. So wait, for the, like, for example, my project and my group about the bus, right? So the sensitivity analysis will be based on which data?
You can select any input of that. And then in fact, you will select all the input that you have. And then you will select, which input actually will produce the largest change in the output. That is in here, the input is only probability. So I change that probability. In your case, I don't know what is the input variables that you will put.
So I can, like, for example,
probability.
So I can input like the number of, like, number of bus.
Yes. Yeah. For example, number of bus or the number of demand, right? Then the output will change, right? But this variable, now you will select which variable actually the most sensitive to your system.
Okay.
Analyzing one by one of each input variable, then you will know oh, this variable is actually the most sensitive, meaning this is the most important.
Okay. So okay, I see. All right.
All right.
Yeah. Okay. Thank
I,
you.
I guess you get the idea, right?
I think so.
You change certain variable into what is the range of the value, okay, and what it will affect the output, which is in this case decision. Yeah, in your case, your output can be what, waiting time.
Yes, waiting time.
Yeah, so
Okay.
so what is the change of input to the output? That is concept.
Okay, so I like, yeah, as you said, number of passes, and then what else, like the number of demand and so on, so that we can minimize the main goal, which is minimize the waiting time.
Correct.
So we have one output, but we change the inputs, so somehow the output is getting greater and greater. Like, I mean, in this case, like
It can be greater or
like,
smaller, we don't know.
yeah, I mean, like greater it means like a better result than the others. Okay, yes, sir.
Correct. Okay, so I hope that is useful. So risk, okay, risk in, if you want to quantify risk, the question is how in finance, no? We quantify risk, right, by setting what is called standard deviation. So if you have data, okay, and then you said, oh, I have a risk. How do you calculate the risk? Okay. Usually risk is computed in terms of standard deviation. Okay. Or you can also quantify risk based on standard deviation divided by the mean. You can also call this return to risk, which is mean divided by standard deviation. Coefficient variation is basically standard deviation divided by the mean. When you call return to risk is basically mean divided by standard deviation. So in general, risk is measured by the variation. Okay, I give you an example. You know McDonald's, right? Have you ever eaten in McDonald's?
Yes.
Yes.
Yes, sir.
So if you go around the world, McDonald's is the same or not?
Pretty much.
Well, the main thing, like they have Big Macs, it's the same, but
okay,
like
there's local variation.
Yes,
but the main part is the same. So when you call standard, okay, when you said, oh, this has quality, what is the meaning of having quality? Quality means the standard deviation is small. You know, quality does not mean that, okay, I will give you an example, okay? In here I will.
So it's consistency also?
Correct, consistency is also quality. So I will give you an example of drawing. Okay, so wait. Okay, I will share a screen with this whiteboard. So I will draw here, okay, in the red. So this is my first product. Okay, I will put this number 1. So let's change number 2. Okay, this is number 2. So this is number 2. So in here is, for example, the strength. Okay, so it's a strength of material, for example. And of course, in the vertical axis, you have probability, right? this is probability. My question to you. Oh, where is the? Sorry. So I will draw again. What happened? It erased by itself. Wait. I will draw again. So this is my product number 1, and this is my product number 2. Okay, the area under the curve are the same. 1, total is 1, right? So my question to you, which product have higher quality, product 1 or product 2? How many people said product 1 has higher quality in terms of the strength? And how many people will say product 2 have higher quality?
I go with number 1.
One, I guess.
Why you said number 1? It's lower in terms of the mean is lower, you see?
Yeah, I think so, but I think like, can I describe it using an like a drawing, like because
Go ahead. You share your screen.
this no with on your whiteboard I can do.
Okay.
Does it show up?
Yep.
Okay, so I chose number 1. This one is a drop, right? Drop and strength. What is this one?
Strength.
This the y-axis is
The y-axis is probability.
Probability or the strength. Because I think like I don't know, the consistency of the product is shown by the width of this curve.
Yes,
of this mountain.
the standard deviation in 1 is smaller.
Yeah, I think so. So I
Okay.
guess number 1 is higher quality because less
Less
like
standard
the width.
deviation.
Yeah, less standard deviation, less deviation.
Right. So sometimes people mistaken quality mean higher in terms of the mean, but it's not. Okay. When you do quality control, what you want is not to increase the strength. Say this is the strength of a material. You don't want to increase the strength of material. You want to reduce the standard deviation. Did you take any course in quality control?
Not yet, I think.
So in quality control, what you want is actually to reduce the standard deviation.
Yes. No, we haven't got the QC class.
Okay, QC class. So the point is sometimes people mistaken, common people who does not know quality control, does not learn about statistics, they will think, oh, of course, higher strength is better, isn't it? Or higher value of that factor is better. No. In fact, when you want to say quality, that means standard. Standard means reduce the deviation, the variation. Okay? So I hope you start to understand the meaning of quality in this case. Okay, so, right. The rest is, I have a few slides there in the slide. If you want, you can read on your own. So this is just a practice. Suppose you have $10K. It is say 150 million rupiah. So if you put in the bank, you get interest of 3% with no risk. Say you have time deposit. If you invest in the stock market with venture business, you get 7% on average, and 10% you lost all your money. So the question is, will you invest your money in the bank or in the stock? So then you can calculate. Okay. But in here, you calculate over time. You know how to compute this, right? The future, okay, I will So this, you know the formula? The future equal to the present value, okay, multiplied by 1 plus k exponent n. Okay, so the future value depending on the present value multiplied by 1 plus the interest rate, okay, multiplied by exponent to the n is the number of years. Okay, with that now you can also calculate the EMV for each decision. Then you can see that you probably want to use bank if the number of years is actually less than certain value, say 5 years. But if you're up to more than 5 years, probably you will select the stock. Can you see it or not? Okay. So decision, the point in here is decision is also dynamic, you know. So also depending on the time. So, and do you want me to put this as assignment or you just do it on your own? So this is exactly similar, but more variation. Yeah. And the output is this one. So probably you want to do it as assignment. Is it okay? Can I give you this? Can I give this as assignment for you?
Yes, I think it's fine.
It's fine. Right? I give you the result here. So you can compute so that you can get the result anyway.
Okay, okay.
Okay, then you can draw this. The purpose of assignment is just to practice actually. Okay, I'll put this as assignment for you so that you can practice. Okay, so you have learned today decision under risk, including the value of information, right? So my question to you, is there any question to me about all of this slide?
Actually, I
Yes,
do want
please.
to ask about the sensitivity analysis since I'm not that familiar with Excel. Do you mind?
Okay. I give you an example. Actually, I do have. Wait a minute. Let me search, okay? I will share my screen. Okay, now I will. In Refoledu, I have data table in Refoledu. There, I have what if analysis. I have one. Okay. So suppose you have this value. Okay. So let's do it. You want? I will create. Can you open your Excel and let's do it together?
Okay.
Okay. Let's do it together so that you can see. Okay, I will close this value information. So I created this new Excel here. Can you see it? And I will put P and K and N, right? And then F. Okay, so because this is number, so I will put 1,000 here, say 0.1, it is in percent, sorry. This one I put it in percent, 10%, right? And then I want to calculate 5 years. This is 5 years. Because these are numbers, so I put yellow so that I know that this is actually my input. And this is your output, okay? Your output is the future value of money. So you have the formula there, F equal to P. Okay, let's make it that way. So this is P. So I put here P, and I put here K, right? And I put here N. Oh, sorry. Okay. So you see, in here I have a variable named P, K, and N. Can you see it in this?
I can see it.
Yes. Now I can calculate. Now F is equal to P multiplied by 1 plus K, okay, and then exponent N. Okay, I got that value. Exactly like in the website, right?
Yes.
Because this is my output, so I put it output. So I put any color there. Now I go to the next. So I want to create a data table of one variable. So here in here, I have K, that will put K, and this is F. Okay. So then K is this K, and F is this F. Okay. So this is my data table. So I'll put here data table. Can you follow?
Oh, wait.
Okay. So this is your first. So I will put this green so that you will see this is the first part of data table. So here I can put it as percentage. Okay. So then I can put any value. Okay. For example, I want to put value. I can put value what? Percentage. So I want to put 1%. Oh, 0.01. Okay. And I want to add with 1. Oh, 0.01. Okay. And then I add this. So this is in percentage. So let's put it in percent. So what happens if I want to change this into a 1%, 2%, 3% until 9%? And this is what I want to know. So again, this is the value that I inputted. So I put it into yellow here. Until here, can you make it?
Yes.
So then what you need to do is you put your mouse, okay, you highlighted this, okay, and then you go to the data table earlier, and because this is in column, so you put it column input column cell, okay, so the input is K, then you put it B3 in here. I will show you in a moment. So here, so this is your data table, right? So I highlighted this one.
Okay.
Can you see it?
Yes.
I go to, where is the, there. In Excel, you have what if data table.
Okay.
Okay. And then, because this is in column, right? So then you put this column is actually K. K is C5 in this case, right? Then you click OK. There, you get it.
Oh, okay.
Okay.
Yes, thank you.
Clear, huh?
Yes, very clear.
Very clear. Now, this is one dimension. Now, you can also have a 2 dimension, meaning that 1 dimension is only 1 variable, right? And then, of course, after that, you can chart, no? Okay. So the next dimension is here. Oh, what happened to this? If you have 2 input variable, like earlier, so the same thing here. So the difference is now you have F, and then now you have N on the right side and K on the column. Can you see this?
Yes.
Okay. Now you want to get the F. Okay. And then, oh, let me do it. This something happened here. So let me do it. Let me change this, okay? So this is now become the F, right? So I will delete this. So the F is now in here. Put this here. Okay, this is the F. And now I have N in here. So this is K a while ago, right? And this is now N. So N is 1 year, 2 years. Okay, I will put 1 plus 1. So I have 1, 2, 3, 4, 5. Okay, until 8. Okay. Now again, you highlight the table. Okay. And you go to conditional formatting. Hey, no, sorry, in data. And then what if analysis, data table, right? What is your input? Your input now is K, right? So you go to K. And what is your column? Your column is actually M, correct? So then you click OK. There, you get the F for the whole N and K. Can you see it or not now? So
Oh,
this
yes.
is result, okay? This is your result. So I color it differently so that you know this is my result. Okay. So this is the whole F for different value of K and different value of M. So in Excel, okay, you have one formula here, okay? Then you can create the sensitivity analysis. You see that?
Mm-hmm.
For 1 or 2 variables. Clear, huh?
Yeah.
Okay, good, good. So I guess this is useful for your assignment, right? Later on.
Yes. Yes. Well.
You will compute that, okay? So data table, okay? Without data table, oh, you will compute one by one. That's crazy. So do I answer your question? Anything you feel doubt, you ask. Especially if benefit other in the class, then you can we can answer in the class. So is it really clear? Okay then. So I hope you do this assignment as a practice, and then I hope you also read the next slide, which is under utility and group decision. Okay, that will be our topic next meeting. Is that okay?
Yes, sir.
If you read before the class, then you will have more questions, right?
Okay.
Okay. Then you get also better understanding. Okay. So I guess this is the time, right?
Yes, sir.
Okay. Good. So thank you for attending the class, and see you next week.
Thank you, sir, for today's class. See you
Yes.
next
Thank you,
week.
sir.
I hope you enjoy this.
Yes, sir.
If
what?
you don't mind, next if like in the next weeks, like I need to ask some questions regarding for the project. Is it okay?
The project you can ask individually.
Yes.
They are different. So during the workshop you ask in the class, but before anytime you can ask the project. You know, you can WhatsApp me, or you can use email, or you can use Facebook Messenger. That's fine.
Okay. Thank you very much.
Uh,
Thank you very much.
Yes.